In this video, we are going to take a qualitative look at the velocity and acceleration vectors for an object that undergoes motion. Specifically, we're going to talk about a car that accelerates, travels a constant velocity, and then decelerates. So let's draw a picture of that. So here's my car, and it's going to start from a stop. So at a stoplight. I'll call that point A. Over here at point B, we're going to have a time which the car is accelerating. So I'm going to make up a number here, just arbitrarily, just so we can talk about some values. Let's say it's 5 meters per second squared. Then from B to C, we're going to coast. We're going to take our foot off the accelerator, or if you're running, you're just going to keep moving at a constant speed. And so during that time, the acceleration actually goes to 0. You don't accelerate. And then finally, from C to D, we're going to decelerate. So we're going to have an acceleration of negative 3 meters per second squared. Physicists just say a negative acceleration, but people outside of physics might say it's decelerating. So to us, it's a negative acceleration. At any rate, let's take a look at the velocity vector. So here we're going to start from rest. So in the beginning of the car, I'll do a dotted line here. Our initial velocity is 0, so you can think of the velocity as a dot. Then it gains a little bit of velocity, so the velocity arrow or vector points to the right here, and it's short, and then it gets longer, and then longer. So as time goes by, this velocity vector points to the right, and its length gets longer. So here we can talk about what a vector is. A vector is a quantity that has a magnitude and direction. The magnitude is the length of the vector. So initially it has 0 length, it's a dot. But then it gets a little bit longer, a little bit longer, a little bit longer. Its magnitude increases, and its direction is to the right. When it gets to point B here, whatever velocity that it has, it's going to maintain. It will not get any longer nor shorter. Okay. And then finally, when it decelerates, the length of the arrow becomes shorter. So here it's longer, and it becomes shorter, and then shorter, and then finally, if it comes to stop here, the velocity is 0. So these are velocity vectors. And as long as the car is traveling to the right, all the velocity vectors point to the right, although you can see the length or their magnitude changes. What causes that change? Well, the acceleration vector. It's also a quantity that has a magnitude and direction. So in this first interval, the acceleration vector points to the right, which you could think of as the arrow that increases the length of the velocity vector. In the second region, the acceleration goes to 0, again by either taking your foot off the gas or throttling down while you're running. So this velocity is neither made larger or smaller. And then finally, when you slow down, the acceleration vector points to the left in the negative direction, hence the negative sign. And you can see here, this vector actually opposes the velocity vector, making it become smaller. If you want to think of it as the wind, you have a headwind coming in towards you, that'll slow you down. And that's what the acceleration vector looks like. And this length, this vector, is 3, which is shorter than this guy, which is 5. So the magnitudes are different. This has a length of 5, if you want to say the length of 5, and this one has a length of 3, and it's in the negative direction. This is in the plus direction because there's an implied plus sign here. So you can see here, this is just a qualitative view of the velocity vectors as something accelerates, travels at a constant speed, and then decelerates. And in this video, we can see that velocities here are vectors. They have a magnitude and direction, and so are accelerations. And one final note, you may hear the word speed used, and sometimes people interchange it with velocity. Speed is just the magnitude of the velocity. So if I just say the number, and I'm just making this up here, velocity is 3 meters per second. The 3 is just the magnitude. I'm not going to say if it's to the left or to the right. So speed is just the magnitude of the velocity. We're not stating a direction. Velocity is a little more specific. It gives me the magnitude and the direction. And if you're in an aircraft, you probably want to use the velocity quantity more than the speed, because if you're traveling in a plane at 500 miles an hour, you also want to specify direction: north, south, east, west, left, right, and so forth. So that's the difference between the word speed and velocity.